Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we talk about polynomials. We're in the Common Core Standard of Expressions and Equations, and we're going to be solving real-life mathematical problems using these polynomials today. Our guiding question is, what are polynomials and how can we describe them? If you've never heard of the term polynomial before, you'll get a good look at them today, and we're going to talk about how we classify. So a lot of different definitions about how we look at different polynomials, because from here on out, we'll be looking at polynomials quite often. Here is a baseball and a bat. There is a polynomial for the equation of hitting a baseball with a bat and watching it fly through the air and come down. So we're looking at a lot of physics, and if you're interested in science, polynomials will be used all the time in things like physics. Whether objects fly in the air, or they fall, or they move around, that's what we're going to be looking at today. Pretty cool stuff. Well, when we look at polynomials, they are really just long equations. In the past, we've looked at linear equations where they're just, y equals 3x plus 2, something like that. But today we're going to be looking at something gigantic like this, negative 3x to the 5th plus 2x to the 3rd minus 5x plus 6. Super long equations, and there's a lot of things we need to learn about them, okay? So here's our definition. Here's the word, polynomial. Write this down. Polynomial, and if you think about it, poly means many, and nom usually means name, so there's many names, many terms here. And what this is the sum or the difference of many monomials. Well, what on earth is a monomial? Let's look at that one. A monomial is a number variable, but with the whole number exponents. So I can have more than one variable together too in a monomial. Here are some examples of monomials. Something like negative 3x squared. Something like 5x to the 4th, y to the 6th, z to the 10th. 0, negative y. These are all monomials. There's one term there to describe an equation, okay? All right, let's start describing and explaining certain polynomials. Well, here's one. Negative 3x to the 5th plus 2x to the 3rd minus 5x plus 6. Here's another one. Getting pretty big, huh? It's crazy how many letters there are and numbers all together in one long equation. Well, what we're going to talk about is you need to think about the order and the way we write things. Notice that the largest exponent comes first. So we have x to the 5th here, x to the 7th there, and then we put all the smaller ones following. Okay? And notice the other thing too is it's going to be in alphabetical order. So we put x and then y, and so forth. This is called the standard form. So if you're ever asked to write a polynomial in standard form, that's what you do. Put the biggest exponent first, then alphabetical order. Okay? Next thing we're going to talk about is the degree of a polynomial. Well, the degree simply is the total number of exponents in a monomial. Well, what does that mean? Let's look at it here. Well, the degree of this term is 5. When you take the exponents of this variable, there's 5 there. Okay? The exponent here is a 3, so the degree of this one is just 3. Well, what about this one? There is no number here. Well, what number can we put there in an exponent? Just a 1. Okay, so the degree of this one is 5 because it's x to the 5th. So the degree here is 5. The degree here is 3 because it's x to the 3rd. And the degree here is 1 because it's x to the 1st power. It's the number of the exponents in that monomial. And then here, there are no exponents to the variable. So it's 0. The degree of this guy is a 0. Let's do this next one down here. And, quick note here is the degree of this polynomial is not 3, 1, or 0. It's the biggest number. It's 5. So this is a 5th degree polynomial. 5. Okay? That's how we're going to talk about it. Let's look at this one down here. Notice there are two variables, and what we do is we add the exponents here. So it's 7 plus 2. So the degree of this first term becomes 9. Because the x has the 7, the y has the 2. Add them together, and you get 9. Whereas this one, x to the 3rd, is 3. What's the degree here? If you said 3, you're right on. Here, 1. Okay? So what's the total degree of this polynomial? Remember, it's the biggest degree. So this polynomial is a degree of 9. Very simple, huh? One of the other terms we're going to look at too is called a leading coefficient. Leading coefficient is simply the number in front of the greatest degree monomial. Well, let's put all those together. It's the number in front of the greatest degree. Well, here, the greatest degree here is a 5. So what number is in front of x to the 5th? It's -3. So the -3 is the leading coefficient here in this polynomial. What's the leading coefficient of this polynomial? Did you say -9? That's right. You just take the number in front of the exponent, or in front of the variables with the exponents that are the highest. Bam, -9. Pretty simple, huh? A lot of definitions, so make sure you get familiar with those, okay? Because you're going to be talking about these quite often here on out. All right, and next thing we're going to talk about are kinds of polynomials. A few more definitions, okay? Bear with me. We're going to talk about the degree and the classification. Well, when the degree of a polynomial is 0, it's just a constant. It's one specific number. It'd be like just having one number there, and that's it, with no variables. Well, if the degree is 1, it's linear. That's what we looked at in the past, y equals mx plus b. The degree is 1. Here, if the degree is 2, it's called a quadratic. A quadratic. 2 for quadratic. If the degree is 3, it's cubic. Think about 3 being a cube. And a 4 is a quartic. Think about 4 quarts. Right? So those are the different classifications. You might be asked to classify a particular type of polynomial. And the other thing we're going to look at is the terms and the names. So if it has one term, it's a monomial. If it has one term, it's a monomial. If it has two terms, it's a binomial. Bi meaning two, mono meaning one term, two terms. What about 3? Trinomial, pretty simple. And 4 more is just a polynomial. Okay? All right, what you're going to be asked to do now is you're going to name the type of polynomial, monomial, binomial, trinomial, polynomial, and the degree. And if it's non-standard form, would you write it that way? All right, let's look at the first one. Negative 4x minus 2x to the third minus 5x to the fifth plus 6y. Is this in standard form? That's probably the easiest thing you're going to want to do first, is write this in standard form. Put the one with the biggest variable in front. All right, and then name the degree of each of these, and then the degree of the total polynomial. What about this guy? You've got 7x squared plus x to the third minus 5y. Remember, you want to take the one with the giant exponent, bring it to the front, and then you've got x to the third plus 7x squared minus 5y. So the degree of this one would be what? Did you say 3? Yeah, the degree would be 3. How many terms do we have? 1, 2, 3. It's going to be a trinomial, and it's going to be cubic. Cubic, because it has x to the third. Okay, 3 different names there. What about this one? Negative 6x cubed plus 5. Well, it's in standard form, so we're good there. Leading coefficient, negative 6. The degree, 3. Cubic, and binomial, because there's only 2 terms. A lot of terms there to memorize, huh? All right, what about this one? Negative 5xy z to the third. There's only 1 term, so it's a monomial. Leading coefficient, negative 5. Degree, 1 plus 2 plus 3 is 5. Total 1, 1, and 3 is 5. All right, ready for the answers? All right, here they are. Definitely go back if you missed one of them. A lot of definitions to memorize, remember. So look at all the different degrees and different names. All right, the equation for something rising and falling, this is where it gets really good. It's like a thrown baseball. If you think about it, it's going to be this. D is the distance to the ground in feet, whereas t is the amount of time has elapsed. 60 is the throwing speed, so if you throw a ball at 60 feet per second. T is the amount of gravity on the pole, or negative 16 is the amount of gravity on the pole. H is the initial height, so if I'm 6 feet tall and I throw it at 6 feet high, throw the ball up, comes on down, I can find out the distance at a particular time. Pretty cool, huh? Imagine this. Here it is. Here's how tall I am. I'm 6 feet tall. I take the ball. I throw it up at 60 feet per second. I take a particular time, say 2 seconds. Bam. This is where the ball is at a particular height. So I plug in the 2 here for 2 seconds. I plug in the 6 feet for H. and it will give me the distance of how tall the ball has flown. Pretty neat, huh? This is where you use polynomials in real life. All right, so what I want you to do is I want you to name the type of polynomial that this is right here. Give me some names and definitions, degrees, classifications. Is it in standard form? All right, what'd you get? Okay, let's do this. So here it is. All right, if you're 6 feet tall and you throw the ball, how high will the ball be at 1 second? Well, let me give you a hint here. What you're going to do is you're going to take 1 second, and you're going to plug that in for t. That's going to be your time. So instead of t right here, you're not going to write a t, you're going to write a 1. And instead of a t here, you're going to write a 1. And I'm 6 feet tall, so instead of a h, you're going to write a 6. Okay, so now what you're going to do is you're just going to simply solve this equation. So negative 16 times 1 squared plus 60 times 1 plus 6. That's going to give you the distance of how high the ball will be above the ground from where you threw it. Pretty cool, huh? Well, what I want you to do is to find out now, plug in 2 seconds. Where's the ball? How high is the ball going to be after 2 seconds? And then when you get that, do 3. All right, about how much time will the ball need to hit the ground? How much time would you guess? Well, I'll give you a hint. Where was the ball at 3 seconds? Was it pretty close to the ground? Did you try 4 seconds to see where it'd be at 4 seconds? And what is D going to equal? Think about it. What is D going to equal at this point when the ball hits the ground? All right, here's a challenge question. Think about it this way. At about what time will the distance be in its height? At its highest. What time will the ball be at its highest? And about how high will it be? Any ideas? All right, well, here are your hints. After 1 second, it's about 50 feet, 2 seconds, 62, 3 seconds, 42, and that's pretty much it. At 4 seconds, your distance is going to be 0 because it's hit the ground. And your time is about 2 seconds when it's right in the middle there, and your distance is about 62, just like we found earlier. Okay, well, that's pretty much it for today. Are you able to answer this question? What are polynomials and how can we describe them? I bet you can. A lot of definitions in there, but I bet you'll get them. Well, that's it as we talked about polynomials today. Isn't that pretty cool that we're learning about baseball and physics and things moving through the air, flying, falling? This is where it all begins. This is where math really starts to become really fun and really cool. That's pretty much it for today, though, guys. This is Matt from mathsmath.com. Thanks for joining us as we talked about polynomials. Check us out on Facebook at Solving Maths Problems, on Twitter, Maths Math, and enjoy math.